N95 masks have an interlaced structure. They are designed to filter out particles, microorganisms, and even viruses, preventing them from entering the respiratory system. This intricate lattice can be seen with a microscope under a 40 times magnification. In a 2016 experiment conducted by Dr. Rajiv Patel of Stony Brook Medical University, scientists set out to better understand mask-related aerosol transmission. This study compared the efficacy of a range of surgical masks and N95 respirators and determined their ability to filter out aerosols during regular tidal breathing and coughing. Dr. Patel demonstrates that the filtration or the mask capture efficiency is significantly impaired by the inability to form a tight seal at the face seal perimeter. Patel also demonstrated that even a simple measure like applying a layer of Vaseline at the face seal perimeter was enough to significantly improve the mask's ability to filter out aerosols. I set out to design a modular respirator that could address some of the main drawbacks seen in surgical masks and N95 respirators, with a hope to provide better protection from COVID-19 in underserved communities. This is a fully electronic respirator device that can be powered by a rechargeable 12-volt battery. It houses a stacked array of filters of different compositions, including activated carbon, which is extremely effective at trapping organic matter. There are also 3 internal UVC bulbs. They emit a short wavelength of light that can disrupt nucleic acids and genetic material. This inactivates viruses and bacteria, essentially disinfecting the internal components between each use. After a month of research, I was able to source raw materials that have been tested for their filtration ability. I designed and built a modular respirator that can be used to protect against aerosols that may contain viruses or other infectious agents. By modifying diving equipment, I was able to reverse engineer and design a modular filtration system whilst ensuring that an airtight seal was maintained.